Hello, everyone. My name is Gurpreet Singh. I'm a senior product manager at Nuage Networks, Nokia. My focus is on SD-WAN. Again, subcategories there: QoS, application-aware routing, NUH, which is a network utility host, and that will be the center of the topic today, and alarms and monitoring. So in the past, I have also done some standardization work at Etsy NFV and OP NFV for operationalizing the NFV deployments.
Hello, everyone. I'm Patrick. I'm a software architect at Nokia. I've been with the company for 5 years now. I've created the architecture of the Nuage utility host, which is the software that we're going to be talking about during this presentation. And I was responsible for comparing HAProxy with other software and the process of choosing the right proxy server in our application. I've been engaged in the open source community for a long time now. I've been contributing by sharing personal projects on old platforms. Now it's GitHub that is dominating, and of course by submitting PRs to existing projects.
All right, thank you, Patrick. So today we'll talk about how HAProxy is instrumental in operationalizing the SD-WAN deployment. So first, we'll go through the various SD-WAN solution components on SD-WAN and the associated requirements for connectivity across these components as well. And also how HAProxy acts as a key enabler to satisfy those requirements. So subsequently, Patrick will talk about the next level of details on how HAProxy is used in the Nuage SD-WAN solution and what new features in HAProxy can help enable additional capabilities in the SD-WAN deployment. And last not the least, but Patrick will also go through a product demo, which is our Nuage utility host, where HAProxy is the core component. Okay. So when we talk about SD-WAN solution or the SD-WAN deployment, some things come to our mind is what is SD-WAN? What is SD, right? It follows the core principles of SDN, software-defined networking. And one of the core principles for SDN is control plane and user plane separation, right? So unlike the old days when we had network entities or network devices where control and the data plane was all embedded in the network entities, network devices, they were distributed all over the place. Then what SD-WAN does is it takes the control plane from the individual network endpoints or network entities, place it in a centralized location. And there are, again, advantages to that. I won't go too much in detail on the SD-WAN side, but one of the principles which I mentioned to you is a separation of control plane and user plane. That's commonly known as CUPS. So SD-WAN adds an additional component there, which is a policy management component. So when we're talking about SD-WAN, the user wants to be able to specify policies, whether those policies are related to security or performance, QoS, or maybe just path selection for some reasons. Let's say they want a certain type of traffic to take a particular WAN connection, whether it's internet, whether it's MPLS network as a WAN connection, right? So all these components, they need to interact with each other. When we are talking about branch endpoints, we're talking about the policy manager, we're talking about the controller, the backend services. And they access services from all these different endpoints or the backend services as well. So the communication across these components, accessing of the services, that needs to happen in a highly secure and high availability manner. Right? That's why the security and high availability becomes paramount. And then load balancing, sure, it's definitely required, but it needs to happen at the right, I would say, at the right scale and the performance which is required for SD-WAN deployment. Now, when you have all these entities, some of them distributed branch endpoints, some of them centralized and all these things, you want to have visibility of what is happening across these different SD-WAN solution components, right? So the branch endpoints are not just generating control plane and management traffic, they are actually also generating traffic for statistics, monitoring data, um, providing communication to web filtering services and several other services. So when you have all these different components, there are multiple points of failure, and we want visibility into this network so we can identify, we can do the root cause analysis. What is the root cause for service health degradation? What is the root cause for service health, service availability, right? So troubleshooting and visibility becomes a key component here. So if you look at these SD-WAN solution components, we talked about the management components, policy manager, backend services, branch endpoints. Now, there is a need for this intermediate entity, or you can say the utility host, which can provide all these services. And that's where HAProxy comes into picture. So HAProxy forms a core component of the utility host, which provides connectivity, proxy services to all the web filtering, upgrade services, test services, load balancing, high availability, and also lifecycle management of the branch endpoints, upgrade of the software. So all these things need to be provided by the utility functions for SD-WAN employment, and HAProxy plays a complete, or I would say a critical role here to provide these services and capabilities. Now, security, load balancing, high availability, and visibility, they form the four key pillars for the requirements that SD-WAN imposes on the intermediate entity or the utility host, which we have referred to earlier, right? In the security arena, we have certificate authentication. So all these components needs to be able to talk to each other using security authentication. Some of the network interfaces on the utility host, they are exposed to application layer DDoS. So there needs to be protection against application layer DDoS. SSL termination, TLS encryption are inherent requirements there, and any component or any solution such as HAProxy need to support this. On the load balancing side, like I mentioned earlier, the load balancing, sure, we want to increase the capacity. We want to provide that redundancy using the load balancing, but it needs to happen at high performance and high scale. And a little bit more, I'll talk a little bit more on this later in my presentation. But on the high availability side, the two key features which the Nuage utility host is using are VRRP and hitless reload. And VRRP again here provides the active passive high availability deployment scenario, hitless reload. no loss of connections when there is a software upgrade for the HAProxy, or there's a configuration reload, right? So that's important. We don't want to have discontinuity in the service availability. Right? So monitoring of service health, monitoring of service performance, providing detailed logs, health checks for the backend services. These are some of the things which HAProxy provides, right? And which we are leveraging in our product to troubleshoot and understanding the performance of the service health. And this is paramount. Some of this information can be used for capacity planning as well, when we are planning the capacity, how much resources to allocate to the utility host and things like that. Okay, so we talked about load balancing. We talked about load balancing needs to be done at high session scale, high performance. So let's dig a little bit deeper into that. So when it comes to session scale and performance for SD-WAN, the utility host needs about 6 to 7 sessions per branch endpoint, right? Which in turn translates to HAProxy requirements for session scale. 2 sessions for service and system stats, 1 for web filter server, 1 for upgrade, syslog, test services, right? So in all, we have about 6 to 7 sessions for each branch endpoint. And in a typical SD-WAN deployment, we could have all the way up to 10,000 branch endpoints. That in turn translates to 60,000 sessions for each HAProxy instance. As we know that HAProxy currently supports 8,000 concurrent TLS sessions per GB of RAM. So with vertical scaling, we could get to 60K sessions, satisfying the requirements for the SD-WAN scale. On the performance side, there are 3 traffic types, which are the key culprits or the bandwidth hogs from a NUH perspective or the utility host perspective. So statistics traffic, which is again traffic for statistics going from the various endpoints to the centralized components. And then we have the software upgrade traffic and the test services traffic. So a combination of these 3 traffic categories, in addition to the control and management traffic, which the utility host has to handle, we believe that 1 gig TLS traffic should fit the bill. And HAProxy currently supports more than that for as far as the TLS traffic is concerned. So we believe that from scale and performance point of view, HAProxy definitely has support for supporting the required scale as well as the performance, right? So one thing which I wanted to note is that when we are talking about performance, it's possible that software upgrades, too many software upgrades happening at the same time, or too many concurrent test services happening at the same time, could starve the control plane traffic. So that is definitely not desirable. So we need to have some sort of priority scheduling so that the control plane traffic gets a higher priority, and we can throttle some of the traffic on the software upgrade and test services. So I want to talk a little bit more about the visibility or the monitoring solution applicable to the utility host. So in a typical monitoring solution, you have a monitoring layer where it's a monitoring database collector, which collects all the metrics, service health statistics from the different entities. And then you have the analytics engine, which operates on all the metrics and the monitoring data which has been collecting to provide actionable intelligence to the operator. On the utility host side, we have two entities, which is monitoring agent, which provides the resource usage monitoring, whether it's CPU utilization, memory utilization, as well as disk IO utilization for the utility host itself. And then HAProxy is providing the service scale, the service health data to the monitoring layer. So combination of all these monitoring data, we can have a good idea on what's happening in the system. We have visibility, we have the ability to troubleshoot any issues which arise. Okay. In addition to troubleshooting and debugging capability and service health, I believe that the information, the monitoring information can also be used for capacity planning. Okay, so with that, I would like to hand over the control to Patrick, who will go over the solution architecture for utility host and some of the associated use cases where HAProxy is used as a core component.
Thank you, Gurpreet. So the Nuage utility host is the entry door on the internet for all the Nuage infrastructure components that reside in a typical deployment. HAProxy is used as the core component for to enable secure communication to these different servers in the infrastructure. So as we can see from this diagram, we have the utility host that sits in the middle of the design, and we've got an external network and an internal network. The internal network is what it says, so it's what's internal to our infrastructure, and then the external network is one of the WAN links, like the internet. And we have branch endpoints that sit on these external networks that need to communicate to these servers on the internal network. So HAProxy is used as well to proxy this traffic. One of these servers is the configuration server. So this is the SDN configuration, or we could call it the SDN policy engine. This is the server that sends the configuration updates to the branch endpoints. It's important that this traffic to these servers be load balanced, because we want to limit the amount of interruption that there can be. So we want to guarantee a high availability for this service. And security is ensured by having TLS traffic and having client certificate encryption, so that not everyone can just start talking to this server. So only approved branch endpoints can get the information from there. And then we have the stats collectors that we call them. Those are statistics collection servers that will collect information about the usage of branch endpoint. We can have many of those servers, so proper load balancing is required for this, to make sure we distribute the load equally among the pool of servers that we have, and to avoid having, to prevent having rogue devices send bogus traffic to those statistics collectors. We do client certificate validation, so that only the Nuage branch endpoints can send traffic to those servers through HAProxy. The firmware repos are basically just plain HTTP servers that will be used for serving firmware upgrades for the branch endpoint. So this will require a lot of bandwidth, and then performance is really something that we're looking for in the utility host for this server, because if we have thousands of branch endpoints that starts downloading, the firmware upgrades, then we really need the performance of the utility host to be on par with that demand. And one of the last box that we can see here, the web filter policy is, this is a pool of servers that we use for establishing policies for browsing or whatever web traffic that the branch endpoint would be trying to access. So if customers behind one of the branch endpoints want to reach a site that should be blocked, then it would reach to that web filter policy server to get a database, a list of valid URLs that it can access or that it should be denied of using. This pool can also have many different, like maybe 10 different servers or 100. There's no limit on the number. So proper load balancing is used to make sure that the whole pool is being used equally, using the whatever rules that we've configured. In a deployment, the branch endpoints, they need to first be activated. So when we ship a branch endpoint device to one of our customers, it's usually a blank device that can't be used anywhere. So they first need to activate it, and to activate it, they need to use there's a sequence, there's an email they get with a URL that they need to access, and then there's this whole procedure to obtain a certificate from the SDN config server to make sure that the branch endpoint can start communicating with the infrastructure. So upon activation, well, as you can see, the proxy sits in the middle. This is the Nuage utility host, and the SDN config server is on our infrastructure side. So at first, when the branch endpoint starts to, when it sends an activation request, the client certificate is checked against the factory certificate authority. So there is a factory baked in certificate in the branch endpoint that is used. And once this is validated, the request to activate is sent to the SDN config server. And then a new certificate is generated and sent to the branch endpoint. And then using that new certificate, it can start doing configuration requests and configuring itself to be communicating with the infrastructure. And using that client certificate allows us also to use a CRL. So if we want to ban one of these branch endpoint or deactivate it, we can always revoke the certificate, and then the proxy server will recognize that this certificate is revoked, so no communication will be allowed to the SDN configuration server anymore. One of the most important aspect of our deployments is the use of namespaces, of network namespaces. In a typical deployment, we have many different external networks. So in this diagram, I'm showing, for example, there are two MPLS networks, and there's the external network here that could be just the plain internet, and the internal network that is the where the Nuage infrastructure resides. One of the very important thing that we're leveraging in HAProxy is the use of namespace support. So in Linux, when we configure these different network interfaces, we place them in different network namespaces. So HAProxy needs to be listening, it needs to have one leg in each of those network namespaces, because each of them could have overlapping address space. For example, they're not only overlapping, but they could be identical. Those two MPLS network could have an identical IP address scheme. So we need to, to make things more simple in Linux, we place them in the networking namespace, and then we can have different front ends inside of HAProxy that sits in different namespaces. All the backend servers in the HAProxy configuration, they reside on the internal network, and we call it the internal namespace in Linux. That's where we place the network interface that accesses the backend servers. So each front end is then bound to one and only one external network. So we can see here the branch endpoints that are attached to different external networks, and one of the branch endpoint it's connected to two external networks. So for redundancy, for example. And of course, when we have a solution like this, we need to be able to guarantee high availability to our customers. To do this, we're deploying the utility host as a pair of servers that are both active, and we're sharing a VIP, so a virtual IP address between the both of them. And each branch endpoint would access the pair of server through the VIP. And this is done with VRP. And the HAProxy Enterprise Edition ships with a modified version of Keep Alive D. This is what we're using to make this happen. So we're configuring a Keep Alive D server to sit in every different namespaces and have VIP in each namespaces or each network, each external networks. So then the branch endpoint can have this communication established as we see here. And a good security aspect to elaborate a little bit more on what we've discussed before of HAProxy is the use of TLS termination and the client certificate. As we can see here, these are the different communication paths that can happen when we activate a branch endpoint. And what we call, when the activation, we call it the bootstrap. And this is what we're seeing here, the branch endpoint going through HAProxy and doing the activation. So there's the pre-bootstrap certificate that we're using, and then there's a post-bootstrap, as I've mentioned earlier. We're using different CAs to validate those certificates, and these are all things that we can configure in the front ends of HAProxy. We can then configure different certificate in the back ends to communicate with the policy manager. And so HAProxy can then be used as I like to call it a back-to-back TLS proxy. So you've got the TLS termination on the front end, but you're re-establishing the TLS communication on the back end also, as we can see here. And then, so we can see the OpenFlow TLS communication here, but this is not going through the proxy. What's really important to understand is those 4 arrows that we see here. Another big thing that people have been asking a lot from us is UDP support for the proxy. So currently, the 3 things that we want to support is NTP, DNS, and syslog. Right now, the Nuage utility host does support proxying of DNS and NTP, but not syslog. But we're not using HAProxy to do those. For NTP and DNS, what we're doing is we're just launching an instance of an NTPD server and an instance of the bind server, the DNS server, and we're forwarding to an upstream server, which is probably the right way to do it. But it would be nice if we could leverage HAProxy to make the whole configuration of everything inside the Nuage utility host use the same process of going through HAProxy to proxy that traffic. So syslog is one of those things that we don't do right now because we're waiting for support from HAProxy, which I believe came out in one of the latest version in the 2.x series. So this is something that we're considering in the future. So one of the big thing that we want to have support for also is support for MTCRL files. So right now, the way it works for supporting the certificate revocation list, we build a HAProxy configuration that that is defined with a CRL in the front-end config. But that CRL, we get it from a different server through a cron job. So if there's some kind of a glitch or a race condition where we start HAProxy, but that CRL was not fetched yet, then HAProxy is not happy and it won't start. So one of the things that would be nice to have would be if HAProxy could read the config and detect that one of the front end is configured with a CRL, I would check if the CRL exists. If it doesn't exist, then just leave the front end down, but HAProxy would still be up, and then it could periodically check again if the CRL becomes existent, and then bring the front end up once that happens. Same thing if the CRL exists but it's empty. It would be nice if the front end could be loaded, but there's just, you treat it as if the certificate revocation list was empty. There's not going to be a signature in it. It could cause a security risk there, but it's all things to think about. As long as the HAProxy server, the load balancer server, would come up successfully with just the rest of the front ends to be up, that would be good for us. I'm going to show you what the Nuage utility host is and how it's built. So we've got a GUI for the Nuage utility host that we can see here in my browser. I'm not going to go through the GUI because that's not what we want to show. I really want to show you what the internal does. So I was talking about the internal, the network namespaces that we're using. So in this window here in the bottom, I have one instance of the utility host, and this one is the second. So as I described earlier, there it's a pair of servers that is being deployed. So if I do this IPNet NS, I can see that they both have the same network namespaces that are being defined. So the internal network namespaces is where the backends are defined, and then those namespaces are WAN interfaces. So this is on a test setup. So we have 4 here. Management is considered of like a WAN namespace also, and in each of them I have for example, internal IPA, I have my own, internal, I have my net NS exec. Yeah, I have my IP address defined here, and they could be overlapping. So I can see ETH5 is placed in that namespace. Same thing for this other server. Of course, I'm going to have a different IP because this is the peer server. This one is .51 and this one is .50. I'm going to show you the HAProxy configuration for this setup. So if I go in HAProxy, so we can see here I've got, so for example, for the bootstrapping that I was talking about, which is using the client certificate. This is one of those configurations. So I have my front end here that uses a certificate for the client validation, and I've got the CA file here to validate that the client certificate is really signed by who we think it is, by our infrastructure basically. And the nice thing in HAProxy right now is that we can specify this namespace keyword so that front end is bound not only to an interface ETH1 in this example, but it's binding to that interface within that namespace because that interface has been placed in that namespace. So this allows us to have one configuration file with many different namespaces instead of having different HAProxy instances sitting in different namespaces. I have here one example that does have the CRL in place. This is what I was talking about. The CRL could be empty sometimes, so this is causing problems for us. We'd like it if we could if that file was inexistent, it could continue to work anyway. So this is for the front end, and then if in the back end we do have, so I'm going to go in this back end here. So this back end here is bound to another namespace that we can see here. So we've got 3 servers. We're doing the load balancing across these, and we're doing the SSL termination on the front end, and we're again doing the SSL termination, well, not termination, but connection on the back end also to this pool of 3 servers. And as you can see here in this command here, we can define another namespace, which is different than the namespace we had above. So we can have the front ends and back ends sit in different namespaces. So that's pretty cool for us. It does exactly what we needed to do. So that's for I'm not going to go through the entire HAProxy configuration. I just wanted to show you how the namespaces are used and the client certificate validation is done. I can show you how the VRP configuration is done. So this is done with Keep Alive. So for example, so one of the things that we don't have right now with Keep Alive D is, so there's a newer version of Keep Alive D that does support sitting in many different namespaces, but in this version that we have, this is not possible. So we have to define one configuration file per namespace. So as you can see here, I have one of those configuration file per network namespaces that I've defined. So if I go at the management one, for example, I define my virtual IP address here, and it's just a standard basic VRP configuration, and with the interface name here. So and then when we launched that service, we kind of wrapped it in a systemd service that will launch multiple instances of those. So we can see here status, we call it proxy VRP. We can see here we've spawned many different instances within that service. So one for each. So there's 2 processes that are being launched because that's the master process that spins another one. But in our point of view, we're spinning one per different namespaces, as we can see here, but we end up with several processes running. So that's it for the VRP here. We can see that was in the management. I can go in the IPNet NS. You can see the VRP probably here. So I do see the VRP that's been assigned here. And of course, on the second server, I don't have the VRP. So this one only has the .51 address, and this one has a .50. But this one also has a .200. So if I were to shut down this server, the first one, then the VRP address would bounce to the second one, and the branch endpoints, they wouldn't notice anything. They would still continue to use the same address, and they would be able to reach the servers. That's our presentation. I hope everyone liked it. Thank you very much for listening.
Yeah, thank you, everyone. I hope that you got to learn how Nuage is using HAProxy and what kind of additional features we could add to HAProxy to strengthen the overall solution and overall, I would say, industry adoption for HAProxy as well. Thank you.
Great, and now we have Gurpreet and Patrick joining us here live. Gentlemen, thank you so much for your talk and for participating in the conference. Welcome.
Thank you.
Thank you, Dylan. Thank you for having us, and it was a great pleasure to be able to talk about the aspects, or you can say how HAProxy is being used in our SD-WAN deployments, how Nuage is using it. So great.
Certainly. So as a reminder to everyone following along, you can submit questions in the chat. You can also submit them on Twitter using #HAProxyConf, and we'll try to get to as many questions as we can. So the first question I have for you guys, what are some of your personal favorite use cases for SD-WAN? Is it connecting IoT devices, maybe connecting remote workers? Really, what catches your imagination? And I know you spoke a bit about this at the end of the talk, but would love to hear you elaborate.
Yeah. So, IoT devices is a very interesting use case. Where mobility is becoming more and more important, of course. Whether we are talking about terminals in the utility vehicles, tracking emissions, or in the public utility vehicles or public transportation vehicles, uh, users with smartphones and tablets, right? So all of these are associated with mobility, trying to access corporate data, which is again sensitive. So they need to have access to those data when they are in the field, right? So the challenge there is, of course, there is a need to somehow do policy management, not only at the branch level, but at the group of users or at the individual user level, right? So there are some solutions out there, and again, you need to figure out whether you want to have your service edge close to the EPC location from the mobile service providers, whether they perform internet breakout for SaaS applications, and also providing a large scale support, because now we're talking about individual subscribers and doing policy management on those, and not just the branch offices. So very interesting use cases and associated set of challenges there. And I would say that Nuage is working on some of those aspects. Then outside Internet of Things, I would like to bring up another use case here is SASE, which a lot of folks on the SD-WAN side have heard about. We're talking about having those secure access functions in the cloud, right? And so key buzzwords associated with those are like, so for example, secure web gateway, CASP, zero trust network access. It's essentially what we're saying is we're talking about um, putting those security functions in the cloud, right? And instead of having it at the branch endpoints completely, and then having a cloud native uh, stack, which is processing those functions as well on the cloud side, right? So those are very interesting use cases. They bring their own set of challenges. So in context to our presentation today, on HAProxy, or how the utility host or the Nuage utility host, is built on HAProxy. Then comes, okay, if we want to move to SASE, then where do we want to deploy the Nuage utility host or the proxy functions, right? Is it in the cloud? If we do want to put it in the cloud, then how does it access the SD-WAN infrastructure components? What are the scale, security, and the performance challenges associated with it? So those are some of the things which you have to handle or tackle. So it's the kind of things, we are looking at it, how we transition to from a SD-WAN vendor to a complete SASE vendor. So we have some of the SASE functionalities already in place, but to get into the leadership board on the SASE side, also some of the challenges which Nuage as well as our competitors and other vendors have to deal with.
Yep. Yeah, and along the lines of the utility host use case, you spoke a bit about this in your talk, but in selecting HAProxy, was HAProxy a natural choice for your team? And can you speak a bit more about that?
Yeah, so I'll let Patrick comment on that. He has in-depth knowledge on that side.
Sorry. Yeah. So at the beginning, I was tasked to evaluate different solutions for the proxy aspect of our product. And HAProxy was one of those products that I evaluated. And it became, evident that HAProxy was what was required for us because of the feature set, and also by how lightweight it is in terms of the footprint. And it's easy to configure. It was easy to configure and install and maintain. So it was the choice we made by comparing different solutions.
I have another question. So you use client certificates to validate which clients are allowed to connect to the backend services. Can you talk about how easy or not that is to set up HAProxy, to set up in HAProxy for those who haven't done it?
Yeah, actually, it's very easy. It's just I think 3 or 4 parameters that you need to put in one of the backend configuration. So what we did is, so you need to create the certificate, of course. Then, if so, the certificate that you put on the client side, you need to have a way of have the client obtain that certificate in a secure way, obviously. So in our case, that certificate is already baked in the hardware for us. And then for the server side certificate, to not the certificate, but CA that we validate the client certificate against. This is just a matter of configuring the back end, the front end. I'm sorry, to configure the front end with the right parameters to check this. So it's very similar to enabling SSL on the front end, except that you're basically specifying a certificate for validating the client. And then there are many options you can check, because then you can get more information about this client certificate. For example, well, I don't have an example right now, but there are many parameters in the certificate that you can pull from your front end, and then you can create ACLs to redirect to the proper back end, or maybe just deny access depending on the client certificate parameters.
Okay, we have time for one last question. So you mentioned how HAProxy can be used for capacity planning. Are there certain statistics that can help out with doing that?
Gurpreet, you want to take that one?
So, sure. So you know, when we are looking at performance and scalability, then what we are talking about is, okay, what are the service statistics? We have to look at the list of services which we are providing, right? Through HAProxy, through Nuage utility host. See, what we have done here is that we have built the Nuage utility host on top of HAProxy, but we have built some added utility services and functions there. Now, those services and functions, we can collect the stats for all those services from the HAProxy, the interfaces and the APIs what HAProxy provides. And we can take that information to decide that, okay, is this service, can we scale more based on the resources which we have allocated to that particular instance of the utility host or the HAProxy? And when we have some monitoring capabilities in place and we are gathering those statistics, we can decide that, okay, do we need to allocate more resources, infrastructure resources, to this particular NUH or utility host instance? If not, then it's great. If we need to allocate more resources, we can do that. That is vertical scaling, right? We are increasing the amount of resources. Now we could also do horizontal scaling, where we can have multiple instances of HAProxy or NUH, and that way we can provide that scaling capability as well. Once you have that monitoring capability in place, you can make those decisions, right? You can set some thresholds where you say, if my resource usage goes beyond a certain point, I can build some automation around it. I can do some auto scaling of the NUH VMs, right, or the HAProxy instances as well, and that way I can do some of my capacity planning. Now, there are some obviously numbers, scaling numbers, which we do publish on how many SD-WAN network endpoints one NUH instance can support, right? So we can take those numbers and then we can do our capacity planning exercise around that.
Yep, makes sense. Great, gentlemen. Thank you so much for your talk and for joining us here for the live Q&A. We really appreciate you participating, and we hope you enjoy the remainder of the conference.
Yeah,
right.
Thank you for
Thank
having
you
us.
so much. Thank you, everyone. And just one last comment I would like to make is that, today's presentation, we did not have enough time for the demo or let's say presenting the demo, but the recording which will be uploaded will have the demo as well for the product. So you can get to see the workflow of the product.
Yep, thank you for bringing that up. That will be listed on the conference website, and then in the coming weeks, we'll actually be releasing it as a series, so that demo will be included there, so you can check that out. Thank you so much, gentlemen. Appreciate it.
Thank you.
Thank you so much.